So here in this problem, we are being provided with a condition that the sum of the three angles of a triangle A, B and C that sums up to pi radians. We need to show that negative sine of angle 2A added to sine of the angle 2B plus sine of the angle 2C, that's equals to 4 times the product of sine of the angle A, cosine of the angle B and cosine of the angle C. Okay, let us begin. So here we'll start our proof from the left hand side. On the left hand side we have negative sine 2A, and to it I have adding sine of 2B and sine of 2C. Okay, so what we'll do, we will first combine the last two terms, sine of 2B and sine 2C, using a standard trig formula, which is given by, if we have, let's say, sine of the angle C added to sine of the angle D, then the sum of two sine function, that's given by 2 times sine of angle C plus D, we have to take the half of that angle, multiplied to cosine of the difference of the two angles C minus D and take the half of that angle. Okay, so in our case here, we'll consider 2B to be equivalent to C and 2C to be equivalent to D. And using the formula, we should get of the first term, we're going to keep it as it is. We have negative sine of angle 2A added to, so sine of 2B added to sine of 2C is going to give us 2 times sine of the angle, so C plus D over 2 means 2B added to 2C all divided by 2, that's going to give us B plus C, multiplied to cosine of, we need C minus D, so C minus D is simply 2B minus 2C dividing by 2, that's going to give us B minus C. Okay, now we can expand sine of 2A. There's a standard formula for this. Whenever we have sine of 2 times the angle theta, it can be expanded to get 2 times sine of the angle theta multiplied to cosine of the angle theta. So here in our case, theta corresponds to A, so we will get negative 2 times sine of the angle A multiplied to cosine of the angle A added to. Now here we have sine of B plus C. So let's use the condition here. The condition is that we are given that A plus, so let's write it down, since A plus B plus C, that's equals to pi radians, we're going to keep B plus C and transpose the angle A to the right hand side to get pi minus A. Now since we need sine of the angle B plus C, what we'll do, we are going to take sine function on both sides to get sine of angle B plus C, and this is going to be equals to sine of the angle pi minus A. Now sine of pi minus A, that's a standard value given by sine of angle A, and it's going to be positive since pi minus A means that we are in the second quadrant where the sine function is positive. Now in other words, we can replace sine of B plus A with sine of angle A. So here we get 2 times sine of, so in place of B plus C, we're going to replace it with angle A multiplied to cosine of the angle B minus C. So here what we can do, we have two terms. Now from each of the two terms, we can factor out sine of A as the common factor, because we see that on the right hand side we have sine of the angle A. So let's take 2 times sine of angle A as the common factor. Okay, so if we take sine of A as the common factor, we'll take the positive term first. So we get cosine of the angle B minus C minus cosine of the angle A. Okay, now cosine of angle A, so again we can use the condition that A plus B plus C equals to pi to find out cosine of angle A. So let's do that. So A is going to be equals to pi minus B plus C. So if we take cosine of angle A, so this is going to be the same as cosine of the angle pi minus B plus C. Now what is cosine of pi minus B plus C? That's going to give us negative cosine of B plus C. We're going to get a negative sign here because we are in the second quadrant, pi minus some angle theta. That means it's in the second quadrant where the cosine function is negative, meaning we now have 2 times sine of the angle A. This is going to get multiplied to cosine of the angle B minus C. So we have negative cosine A. So negative cosine A is simply going to become positive cosine of the angle B plus C. Okay. So what we have is the sum of two cosine function. Now whenever we have the sum of two cosine function, it transforms into product of two cosine function. That means if we have cosine of the angle C added to cosine of the angle D, this is going to be 2 times cosine of the angle C plus D over 2 multiplied to cosine of the angle C minus D. We take the difference of the two angles and divide it by 2. So in our case here, we can consider B minus C to be equivalent to C and B plus C to be equivalent to D. So that's going to help us rewrite the formula. So we have 2 times sine of angle A, that's fine. Now sine of C added to sine of D, that's going to be cosine of, so we need C added to D. Meaning B plus C added to B plus C, that B minus C added to B plus C, that's going to give us 2 times the angle B. But we have division by 2 as well, so we'll get 2B over 2 multiplied to cosine of the angle. Now we need C minus D over 2. So C minus D means B minus C, and from here we subtract B plus C. That's going to give us negative 2C whole divided by 2. Now we are going to further simplify to get 2 times sine of the angle A. I have missed out a factor 2 here, a factor 2. So, because in our standard formula we have this factor 2. So 2 multiplied to 2, this is going to give us 4. So we have actually 4 times sine of angle A multiplied to cosine of 2B over 2, that's simply cosine of angle B. Now we have cosine of negative 2C over 2, meaning we have negative C. However, we know that cosine is an even function. So cosine is an even function means, so whenever we have cosine of negative some angle theta, this is the same as cosine of angle theta. That's because cosine is an even function. That's the property of even function. So since cosine is an even function, what we now finally get is 4 times sine of angle A multiplied to cosine of angle B times cosine of the angle C. And this is exactly the expression on the right hand side. So let's verify. We need 4 sine A cosine B, 4 sine A cosine B, cosine C. So here we have successfully verified that, hence the left hand side equals the right hand side. So our proof is done.